Hi everyone. So your first lecture is going to cover significant figures and rounding, but I wanted to make a quick video on significant figures so that you know what you should be thinking about and what you should practice, what you should look at before actually coming to class. Significant figures are very important in science. I'm sure you've heard of them already. If you haven't, you will, but they're very important in science and math and physics. If you're going to be a scientist of any sort, you need to know how to work and recognize and calculate correctly significant figures. And there's a lot of words on the screen, and we're going to actually go over that during class. You're more than welcome to read it if you want to stop the video. But for right now, I just want to quickly go over the 4 rules that I have created. Your book, if you have your book has 5 rules. I've basically condensed those rules down so to make it a little bit easier. So the purpose, once again, of sig figs is to be able to report the correct number of data points in your calculation. It's very important. So for example, I'm a chemist. If I were to report data incorrectly, like give basically the wrong number of digits with a particular instrument that I was using in lab, and that instrument is very popular, other scientists around the world know how many digits I should be reporting, but yet I report something wrong, that is very bad. I won't get published and I'll lose my job and I'll be very unhappy. So I'll be very sad. So it is very important that I understand how to report the correct number of digits. The first step to do that is knowing the rules of significant figures. So what that means is if I show you a number, you're able to tell me right off the bat how many sig figs it has. So the first rule for significant figure is really easy. It's right here. It's number 1. It says all non-zeros are significant. So a non-zero number is any number that's not 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So obviously you have some examples here. If you have, let me make this a little bit bigger, but if you have the number 14, how many significant figures do you have in the number 14? That would be 2. If you have 2.25, there's no zeros there, right? So you would have, that number would have 3 sig figs. So it's a very simple rule. It's sort of like a dum-dum rule, but it's very important. Okay, let's go to rule number 3 before we go to 2, because I think 3 is a little bit easier. Rule 3 says zeros trapped between non-zero digits are significant, right? So look at the examples they give you here. 409. Obviously that 0 between the 4 and the 9 is trapped, right? So I call that sandwiched. It's sandwiched in between the 4 and the 9. Therefore, there's no way that that 0 cannot be significant. It has to be significant. So when I count the total number of sig figs in that number, I would have 3, the 4, the 0, and the 9. And that sort of makes sense, right? Let's go ahead and skip the second example and go to the third example, 2002. 2002 would have how many sig figs? Hopefully you very quickly and easily responded to 4, and that is correct because the 2 zeros are sandwiched in between the 2's, the 2 2's on either side. Super easy, so that's already 2 of the rules. The third rule, let's start talking about zeros, and zeros are where most students have issues, but there's 2 rules dealing with zeros, the zeros before rule and the zeros after rule. So let's talk about the zeros before, and I call them leading, because they lead the number, right? Leading zeros. So leading zeros, rule number 2 tells you that leading zeros are not significant, ever, right? Ever, ever, ever. Why? Well, because they're not really part of the number. They're actually holding the place for the actual number. So you don't need to count them as part of your data. So for some examples that I can give you are 0.125. That number would have how many sig figs? I hope you said 3, because it is correct. It has the 0 at the beginning, does not count because it's leading. It's before the first non-zero digit, which is the number 1. What about the second example? The second example is 0.0054. There, what's the first non-zero digit? It's that 5. So that means that everything before that 5, since they're all zeros, they don't count. So that number will only have 2 sig figs. It's pretty easy, right? These rules are not hard at all. You just have to remember them. And then the last rule are the zeros after rule, the trailing zeros, that's what I call them. So this is the tricky one. Trailing zeros are only significant if you actually see a decimal point in the number. So let's focus on those numbers that I have right there. So the first number is 700, and you see how the first 700 doesn't have a decimal point? Right there, that number only has one significant digit, and it's the 7. Okay, so that's my first number. Look at the second number. The second number is the same number, right? It's 700. The first number is 700, and the second number is 700. So I know what most of you are thinking. What the heck is the difference if I put a decimal place? We'll get to that later. But first, I want you to tell me how many sig figs you think are in this number. And I hope you said 3. Because if you look back at the rule says trailing zeros only count, they're only significant if you see a decimal place. That example has a decimal place in that number. It's right there. So that means that these zeros here are trailing, right? They're behind the last non-zero digit, which is the 7th. So that means that those zeros must count in the data, must count in the number. I have to count them. So that is why that number there is 3 sig figs. Okay, so another example, let's not use this example, but let's use maybe another example. If I did 1.05020, right? So here we have a couple of rules that we can apply. We have number 1, we learned about the sandwich rule, right? So those 2 zeros are sandwiched. These numbers here are non-zero digits. So already I have 6 significant figures. So the only thing that I'm really looking for is this last 0 right here. And according to the rule, it says trailing zeros, and this is the only trailing 0 I see in this number. Trailing zeros count if I see a decimal place in the number. Well, here's the decimal place way back here. And you're like, yeah, but it's all the way back there. Yeah, but that counts. So if there's a decimal place in the number, then that means that every trailing 0 counts. Weird, huh? So how many sig figs does this example have? This would have 1, 2, 3, 4, 5, 6. So it has a total of 6 significant figures. That's it, ladies and folks. I mean, that's really the rules that you need for significant figures. I do want to explain that crazy thing that I said about the difference, right? So we said 700 and 700. Why the heck would it be a different number of significant figures if it's the same number? That should blow your mind. And here's the deal. The deal is that when you say this and you report it just the number, right, with no decimal place, what you're saying is that your answer, your data point, is closer to 700 than it is to 600 or 800. So see, you're creating a range, right? And the range is plus or minus 100. It's a pretty big range, not that good. If I go over here to the second example, the 700 plus a decimal place, now I'm telling you that my answer, my data point, is closer to 700 than it is to 699, because where's that decimal place? That decimal place is in the ones place, right? So it's closer to 699, it's closer to, it's closer to 700 than it is to 699 or 701. You see how the range now has shrunk, magnificently. Now you're only your answer, your correct answer can be anywhere in between 701 and 699 versus 800 to 600, which is a better number. this is the better number, right? And then you can get even more explicit because you know now that the trailing zeros count, right? So if I said that my number now is 700.0, you know that that trailing zero counts because of the fourth rule that we talked about. And you know now that your answer, right, if you're reporting this data point, your answer is closer to 700.0 than it is to 700.1, right? That's the range up here, or down to 699.9. See how the range shrinks? And it's obviously better. The more significant digits you have, the better your data point, the more accurate and precise your data point is. All right, so that is what I want you to think about. And I actually want you to look at your book and look at the section for handling numbers. That's the section, that's what it's called in chapter 1, handling numbers. So that talks about scientific notation, it talks about significant figures, and it talks about rounding. I want you to look over that, and I actually want you to look at these videos, that the links I have posted here. They're in my YouTube channel. Some of them are, some of them might not be, but here are the links. And then I also want you guys to think about these questions before you come to class so we can discuss them. All right, thank you for chilling with me and learning with me, and I will talk to you soon. Bye-bye.